Can you describe what you see on the screen real quick?
There's a 3D model of a brain in the center, made up of many small dots. On the right side, there are controls to select the seizure type and buttons to start the simulation, play a demo, and reset.
Okay, can you have a look at the demo? I'm not sure if it's going through all the seizure types. Can you just keep monitoring it?
It started with the myoclonic seizure, and now it's showing a focal seizure. The dots on the brain model are changing colors, and their activity patterns are shifting. It seems to be cycling through different seizure types.
Okay, question is it cycling through all the seizure types or just some of them?
It looks like it's going through a few different types. It started with myoclonic, then showed focal, and now it's showing generalized tonic-clonic. It seems to be cycling through these specific types in the demo.
Okay, so how would you improve this web application?
Well, to improve it, they could add more detailed explanations of each seizure type and provide real-world examples. They could also make the visualization more interactive, allowing users to explore different brain regions and activity patterns. Additionally, adding options for different viewpoints and perspectives could enhance the understanding.
Also, can you look at the brain itself, the brain model? How would you turn it into two hemispheres?
To turn it into two hemispheres, you could split the existing brain model down the middle into two symmetrical halves. Then, you could program the simulation to show the activity in each hemisphere separately, perhaps with different colors or patterns to represent distinct activity levels. This would allow for a more detailed understanding of lateralized brain activity during seizures.
And what do you think the difference between startSimulation and the play demo is?
Based on the context, startSimulation likely begins a real-time simulation based on the selected seizure type, where you might be able to adjust settings. Play demo, on the other hand, seems to play a pre-recorded sequence, showcasing different seizure types and their effects on the brain model in a set order.
Well, yeah, that's right. The stop demo takes a long time, not sure why.
It seems to be slow in stopping the demo. That could be a minor glitch in the simulation, or maybe it needs to complete a full cycle before stopping. It's taking a bit longer than usual to respond to the stop command.
Okay, and I don't think you can see the drop-down menu. I think I'll have to read it out to you. So we have focal seizures, generalized tonic-clonic, absence, whatever, French pronunciation. Can you do French pronunciation? Then we have tonic seizure, atonic drop seizure, myoclonic seizure.
Oui, bien sûr. Alors, il y a les césures focales, les césures généralisées tonico-cloniques, les crises d'absence, les crises toniques, les crises atoniques ou de chute et les crises myocloniques. Voilà comment je les prononcerai en français.
Okay, that's great, but I was asking you to do English, so still doing English, but with a French accent.
Oh, apologies. I understand. I can continue describing the web application in English with a French accent. So, as I was saying, the simulation shows different brain activity patterns for each seizure type, like the focal seizures, generalized tonic-clonic, absence, tonic, atonic, drop, and myoclonic seizures. The demo cycles through these to illustrate the variations.
Okay, so can you go overview what we spoke about before and go over a detailed explanation as to how would you improve this simulation, the visualization, and making sure the play demo and the other functionality is working correctly?
Certainly. We discussed the brain seizure simulation application, noting that the Stop Demo button had a noticeable delay in responding. We also talked about the different seizure types available in the simulation, such as focal, generalized tonic-clonic, absence, tonic, atonic drop, and myoclonic seizures. To improve the simulation, several enhancements could be made. Firstly, optimizing the Stop Demo function to ensure immediate responsiveness would be beneficial. This could involve refining the code to interrupt the simulation more effectively. Secondly, enhancing the visual representation of the brain activity could improve clarity. This might include using more distinct colors, patterns, or animations to differentiate between different brain activity patterns during seizures. Additionally, Incorporating more detailed explanations or tooltips within the simulation could provide more educational value for users. Finally, ensuring the simulation runs smoothly on various devices and browsers would enhance the overall user experience.
Okay, and what else would you improve?
To further improve the simulation, we could consider adding interactive features. For example, allowing users to select specific brain regions to observe the activity, or perhaps adjusting parameters to see how they affect the seizure patterns. Also, integrating real-time data visualization or providing more context about the different seizure types with real-world examples could make it more informative. Furthermore, incorporating features like adjustable speed or a pause function to examine specific moments would enhance the user interaction.
Okay, can we keep it more specific with how the current web application looks like, the layout of the page and things like that? Also, the fact that those sticky items how would you make them go over the canvas only and not the entire page? As you can see, can you suggest any improvements?
Understood. Focusing on the current layout, one improvement could be to make the control panel with the seizure type and buttons more visually integrated with the simulation area, perhaps placing it directly adjacent to the visualization without overlapping the quick guide. Regarding the sticky items, like the quick guide, to prevent them from covering the entire page, their positioning could be constrained within a specific container or designated area, on the side or bottom of the canvas, instead of the whole viewpoint. This way, they remain accessible without obstructing the primary simulation view, especially during interaction.
Okay, and how about making sure the demo mode is cycling through all the seizure types? Can you explain that properly?
Understood. To improve the demo mode cycling through all the seizure types, we can ensure that the application clearly transitions between each seizure type, perhaps with a distinct visual change and a clear label indicating which type is currently being displayed. We can also adjust the duration of each demonstration to make sure users have enough time to observe the specific patterns of each seizure type. Additionally, incorporating smooth transitions between different seizure types can make the demo more engaging and easier to follow. Clear feedback mechanisms, like a progress bar or a list of seizure types being shown, can help users track the progress of the demo cycle.
And again, can you explain in detail how would you improve the actual model of the brain, making sure it looks like a brain, has two hemispheres, so on and so forth?
To improve the brain model, we can enhance the visual representation to make it more accurate and detailed, resembling a brain with its hemispheres. This could involve using a more complex 3D model that captures the structure of the brain, including the different lobes and hemispheres. We can also implement more realistic visualizations of the brain activity within these hemispheres, using different colors and patterns to represent the spread of seizure activity. Additionally, incorporating the ability to rotate and zoom in on the brain model would allow users to explore the seizure activity in more detail and from different angles. We could also include annotations or labels to highlight specific brain regions affected by the seizures, providing more educational information.
I don't want to add anything, it's already pretty crowded, so just can you summarize all the changes that we have to make? We have this experienced JavaScript developer that we're going to be sending this to, so can you do an overview of what they have to do and any questions for the developer?
Certainly. To summarize the key improvements for the JavaScript developer, first, optimize the Stop Demo button to ensure immediate responsiveness. Second, enhance the brain model visualization to be more accurate, including the hemispheres, and provide more detailed brain activity visuals. Third, refine the demo mode cycling to clearly transition between seizure types with clear labels and smooth transitions. Additionally, consider adding interactive features like adjustable speed, pause, and improved brain model interaction with annotations. The goal is to enhance the user experience and the educational value of the simulation. Does the developer have any specific constraints regarding the implementation or the technologies they should use?
Yeah, the developer doesn't have any constraints. Can you ask any other and you have a question specific to the layout of the web application as you can see it at the moment.
Okay. Without any specific constraints, the developer has flexibility in implementing these changes. A key focus could be on ensuring the performance of the enhanced brain model and interactive features, especially with real-time visualizations. The developer could use various JavaScript libraries or frameworks to implement the 3D brain model and interactive functionalities. They should also ensure the application is compatible with major browsers and consider different device screen sizes. It might be helpful to prioritize the performance and responsiveness of the interactive elements to provide a smooth and engaging experience. Does the developer have any constraints regarding performance or specific technologies to use?
We'll stop that. The call with prompt engine is like 4 gigabytes. Not sure why it's so large. Then we have it in Copilot. We'll be using Copilot. Not sure what the agent is better. Let's do Claude Sonnet 4. And we'll let it work. See what it can come up with. Maybe we can have can you have a quick look about this? So this is a request for a developer. If you can read this text, and this is what currently the developer is doing. How are they doing? Can you summarize what's going on?
From what I can see, the developer is working on improving a seizure simulation application. They're focusing on repositioning control panels, enhancing the brain visualization, making the stop demo button more responsive, and adding interactive features like adjustable speed and pause. They seem to be reviewing the code systematically to understand the current structure before implementing the improvements. The developer is currently working on improving the control panel. They've repositioned it, and now they're adding new elements to it. They also mentioned enhancing the brain visualization, making the stop demo button more responsive, and adding interactive features like adjustable speed and pause for the simulation. They seem to be making those changes in the index.html file. After repositioning the control panel and adding new elements, they are now working on repositioning the info panel to be contained within the simulation area. It looks like they are also checking the changes they are making. Right now, the developer is focusing on repositioning the quick guide to a designated area. They are adjusting its position within the simulation area. Next, the developer is planning to add some CSS improvements for the demo indicators and styling. This should enhance the visual appearance of those elements. After working on the styling, the developer is now adding brain hemisphere labels to the HTML. This should help in enhancing the brain visualization and make it more conformative. Now, the developer is moving on to the JavaScript code. They are enhancing it to add all the new functionality, starting by adding new variables and UI element references. This will allow them to control the new features and improvements. They seem to be making steady progress on the improvements. However, it's not clear from the current view if they've addressed all the potential interactive features like adjustable speed and pause for the simulation in the JavaScript code yet. They might still need to implement those controls and integrate them properly. The developer is now enhancing the JavaScript code to make the brain particle creation more detailed and hemisphere-specific. They are also adding new camera view functions, which should allow for better interaction and exploration of the brain model. The developer is now enhancing the demo mode with better transitions and progress tracking. They are also adding the pause resume functionality and speed control, which will provide more interactive control for the user. The developer has been working on several improvements to the seizure simulation application. They repositioned the control panel and info panel, added new elements to the control panel, repositioned the quick guide, and added CSS improvements for the demo indicators. They also enhanced the brain hemisphere labels and are currently improving the JavaScript code to include more detailed brain particle creation, camera view functions, and interactive features like pause, resume, and speed control. All right, let's see what the developer is up to now. After all those control panel and brain enhancements, it looks like they're finally making the simulation more interactive. They've updated the UI state function to handle the new pause button, adjusted the resetSimulation function to work with the new elements, and are now making improvements to the startSimulation function for better demo mode behavior. It seems like they're finally wiring up the controls. About time they got to the interactive stuff. was starting to think they were stuck in layout limbo. Now they're working on the crucial part, fixing the update current seizure display call and adding event listeners for those new controls. It's like they finally realized the simulation needed to be, well, controllable. Let's help these final tweaks make it all come together seamlessly, without any spectacular crashes, of course. Wouldn't that be a dramatic ending to this coding adventure? Well, it seems the developer has stumbled on a classic coding mishap, a duplicate function definition. They're now removing the extra current seizure display function. After that, they're planning to update the quick guide with the new bullet point mentioned in the HTML. Just another little debugging adventure for our coding hero. The developer is now fixing the issue where the simulation was not loading and the brain model was not appearing. They are also updating the event listeners to ensure the new controls work correctly. It looks like they're tackling the core issues to get the simulation running properly. Well, it seems our intrepid developer has finally discovered that the core of the simulation is missing.
Okay, we lost our prompt engineer. And yes, there's a human in the loop if you have any questions. Okay, so as you know, everything we do eventually available on this website called bionichaos.com. Go check it out and provide your feedback. There are tools around neurology, cardio, imaging, vision, hearing, muscle, and more. And don't forget to smash that like button. Hopefully we can get this brain seizure simulation up and running. We had the agent, one of the agents, working on it for a while. We had Claude Sonnet 4 doing some work. We need another prompt engineer. Let's call the prompt engineer again. They hanged up on us before. Hey, can you review this request to the developer that you currently see on the screen? And then we go over what the agent developer was doing to address, to improve this web application. If you can have a look at the text, that would be great. I think I actually have to keep talking for you to keep looking at the screen and reading the text. I'm not sure how it works, but still doing stuff. Apparently it's failed, so if you have any funny comments on that, go for it.
The developer is working on a seizure simulation application. The request involves improving the layout by repositioning the control panel, enhancing the demo mode with clearer transitions and labels, making the brain model visualization more accurate, and adding interactive features like adjustable speed and pause controls. The developer is currently working through the code to implement these changes. The developer has been working on repositioning the control panels, updating the demo mode, and enhancing the brain model visualization. They've also tried to add interactive features like speed control and a pause button. However, it seems there's a JavaScript error, specifically a duplicate function declaration for update current seizure display, which is preventing the simulation from loading. The developer is now trying to fix this error and get the simulation running correctly.
Okay, we keep losing the prompt engineer, not sure why. Okay, we get this simulation working again. The brain still doesn't look like a brain, really. Didn't finish the simulation, still working. Hey, can you tell me what changes the developer have made to the code?
The developer removed a duplicate JavaScript function that was causing an error and added a version comment to the main script.
Hey, can we ask the developer how would you improve the layout and how would you make the brain model more realistic? 2 hemispheres, things like that.
It looks like it's going to refine the layout to make the controls and information easier to use. Also, it's planning to make the brain model more realistic by adding more details like hemispheres to make the simulation more accurate and engaging. It's also going to improve the 3D brain model by changing it from a simple sphere to a more anatomically correct ellipsoid shape. It also plans to use more sophisticated distortion algorithms to create a more organic and detailed representation of the brain hemispheres, including subtle asymmetries. You're right, the left and right labels might be confusing when the brain is rotating. A better approach would be to use terms that refer to the brain's anatomical hemispheres, such as the left and right hemispheres, regardless of its current orientation. Yes, removing the labels from the canvas could avoid confusion,
The information about the left and right hemispheres could be presented clearly in the sidebar, alongside the other controls and information. Yes, the AI assistant suggested improving the brain model to be more anatomically correct and to apply sophisticated distortion algorithms to create a more organic and detailed representation, including subtle asymmetries to make it more realistic. This would help differentiate the hemispheres more clearly. You'd like to simplify the hemisphere displays by removing the complex distortion algorithms and also make the hemispheres a bit more separated for better clarity. I can explain how to do that. Essentially, you'll need to adjust the rendering code to remove the distortion effects and modify the positioning of each hemisphere to create more space between them. This should give you a clearer, simpler view of the brain hemispheres. The agent is currently applying changes to the index.html file. It's removing the labels for the hemispheres on the canvas to avoid confusion, and it's also clarifying the hemisphere selection information in the sidebar. Additionally, it's updating the code to remove the distortion algorithms and adjust the positioning of the hemispheres to create more separation between them. Well, it's trying to simplify the display by removing distortion, which sounds good on the surface. But if it removes all the distortion abruptly, it could make the visualization lose some important detail or context. It might end up looking too simplistic or flat. Also, if it increases the separation too much, it could distort the spatial relationship between the hemispheres, which might be misleading. It's a balancing act between clarity and preserving the accurate structure. They need to make sure the simplification doesn't sacrifice important information. Also, just removing distortion might not be enough to make the display perfect. There might be other factors they need to consider for a truly clear visualization. It's like trying to fix a blurry picture by just removing shadows. It might help somewhat, but it won't always make it perfectly clear. Certainly, to achieve a clearer and more separated display of the brain hemispheres, the distortion effects need to be removed. This involves modifying the rendering code, likely in the index.html file, to eliminate those effects. Additionally, the positioning of each hemisphere should be adjusted to increase the space between them, making the visualization much clearer. The developer is currently removing the labels from the brain hemisphere display on the canvas to avoid any confusion with the rotation. They have also updated the labels in the sidebar to be more descriptive, and now they are removing the label code from the canvas itself. The developer is now working on removing the distortion effects from the brain hemisphere display. They're adjusting the rendering code to simplify the visualization and make it look clearer without the distortions. Well, it seems like they're trying to give the brain hemispheres a bit of personal space by increasing the separation. Maybe they were feeling a little cramped before. It's like they're giving the brain a clearer, more organized view of itself. Yes, I can see the front panel of the brain seizure simulation. It looks like it has essential controls like start, pause, play patterns, and reset, which are standard for simulations. It also has settings for seizure type and topic, which provide flexibility. The View and Settings section with speed and sound controls is useful for customization. Overall, it looks like a well-organized interface for controlling and monitoring the simulation.
Papa, keep losing the prompt engineer. There is a human in the loop, by the way, if you were wondering. I think we have Gemini 2.5 stuck a bit. Shall we stop it? It's still editing something. Still trying to edit the file. A sec. Okay, I might have to restart Visual Studio Code. Let's get to the agent again. Let's try a simpler model. Hey, can we simplify the model, the brain model, the data points? Yeah, we don't need that. It can be symmetric, that's fine. But we want to be able to see the two hemispheres. Can you look into the code?
Absolutely. To simplify the brain model and make the hemispheres clearly visible and symmetric, I will remove the complex distortion and asymmetry code from the create brain particles function.
Okay, let's can do it quietly. Can you review what is the developer agent is doing at the moment, where my mouse cursor is?
The agent is applying changes to the index.html file, specifically reading lines from 1 to 1442. It's working on simplifying the brain model to make the hemispheres clearly visible and symmetric.
Okay, and what changes did it make?
It looks like it removed complex distortion and asymmetry code and replaced it with a simpler, symmetric ellipsoid for each hemisphere, separated by a clear gap. This should make the visualization much cleaner.
Okay, I kinda can see the two hemispheres, but yeah, maybe we can ask the agent how it can be improved further.
You could ask the agent if there are ways to further enhance the separation or improve the visual clarity of the hemispheres, or perhaps adjust the symmetry if needed. You could also ask about any additional customization options.
Yeah, this dot randomization at the moment doesn't look great. We don't need it to be random. We can have less data points, but I want to be able to see the two hemispheres and potentially other parts of the brain. Can you explain it properly?
Okay, I understand. The goal is to create a clearer and more structured visualization of the brain, focusing on the two hemispheres and potentially other parts without relying on random data points. The agent can simplify the model by using symmetric ellipsoids for the hemispheres and ensure there's a clear gap between them. It can also work on representing other brain structures more clearly, possibly by using distinct shapes or visual elements for each region. The focus should be on a more defined and understandable representation rather than random scattering of points.
Well, actually, the random points are okay. It's just that we still want to be able to see the different parts of the brain, so the two hemispheres and other parts as well.
Ah, I see. You want to keep the random points, but make sure that the different parts of the brain, including the hemispheres and other structures, are still clearly distinguishable. The agent can modify the visualization to ensure that the different regions are represented clearly, perhaps by adjusting the size, color, or positioning of the random points within each brain region, while still maintaining the randomness. This way you get a balance between the random distribution and the clear delineation of brain structures.
There's also something weird is happening. If we can ask the agent if he can explain it properly. There's something weird going on with the... So when we hit the front button, side button, or top button, the brain does change the orientation, the view changes orientation, but then after a second it comes back to some sort of weird side view. So can we look into that as well? Can you explain it properly?
It sounds like there's an issue with the view persistence. When you press the front, side, or top buttons, the view changes correctly, but then it reverts to a side view after a short time. The agent can investigate the code that handles the view orientation and persistence. It should ensure that the selected view remains active until another button is pressed, instead of automatically reverting to a default side view. The agent can fix the logic that controls the view state to maintain the user's selected orientation. The agent is currently updating the brain region visualization to enhance clarity. It's adjusting the appearance of the hemispheres and other regions, likely using color or slight position tweaks to make them clearer while maintaining the random distribution. After this, it will address the view persistence issue by updating the camera or view logic. Well, it seems like the agent is trying to give the brain model a bit of a makeover, making the hemispheres and regions stand out more clearly. It's like it's giving each part its own unique color or position so they're easier to distinguish. And the view persistence fix is like teaching the model to remember which way you want to look at it, so it doesn't keep changing back unexpectedly. It's like the model is trying to be more reliable and easier to work with. Yes, the agent is following the correct approach. It's first focusing on enhancing the brain region clarity by making the hemispheres and lobes more distinct, which is exactly what you requested. Then it will address the view persistence issue to ensure the selected view stays until changed. This step-by-step approach is logical and comprehensive for resolving both requests. The agent has finished making the improvements. It said that the brain region visualization is now more distinct, with each hemisphere and lobe color-coded for clarity while maintaining the random distribution. It also fixed the view persistence issue, so the selected view, like front, side, or top, will remain until you choose another, instead of automatically reverting. It looks like there's a JavaScript error related to an undefined function called onWindowResize. This error might be occurring because the code is trying to use a function that hasn't been properly defined or included in the script, possibly during the initialization process or when handling window sizing. The agent should investigate the code near lines 792 and 1328 to identify the source of this error and fix the function definition or call. The agent is defining the onWindowResize function now. This function will be used to update the camera's aspect ratio and the renderer's size when the window is resized, which should fix the error you were encountering. It's essentially setting up the code to properly handle window changes for the 3D view. Well, the application seems to be a 3D visualization tool for the brain, perhaps designed for studying seizures or neurological activity. So far, we've been improving the visual clarity of the brain regions, making the hemispheres and lobes easier to distinguish, and fixing an issue where the view kept reverting. The agent has been working on the JavaScript code to ensure the brain model is displayed correctly and that the viewing angles resist as expected. It's like giving the brain model a better visual experience for users to explore its details more effectively.
Okay, there is a human in the loop. Eventually this application goes on to bionichaos.com. Go check it out. Let us know what you think. And don't forget to smash that like button. And yes, this is another tool we made. Well, Gemini made. Currently we're trying to get this brain seizure simulation. Well, correct will be an overstatement. We're just trying to make sense of it. In atonic seizure, it's doing a fall as if the brain had fallen down thingy. It's a bit much. Yeah, myoclonic does a really random stuff. What does it say? Consciousness is usually not impaired. Okay. Yeah, we need to go over the seizures. See if what we can improve.